why we can't use a chi-square test to determine whether these two distributions differ significantly? I remember somewhere, the cells need to be bigger than 5. Do you remember
Right,
that?
for the conditions, yeah.
I mean, and that's it.
Okay, really? So it's just like the conditions are not met.
Yep. Although I would still run one just to see, what
Right.
it ends up happening. But I double check your notes. I mean, that's what I see here. I don't want to, but it can be that simple. Because you mentioned 33. I'll bet 33 says,
Oh, it's the same one.
yeah. But if you look at the answer, maybe that will help here. The 33 is in terms of percentages, but because the total is, well, do we know how many travelers? Usually it's counts. So like, I don't want to say this. So in like 33, where your table has percentages, we need to know like the actual counts. So we know the total number of people sampled to know, because it's not that 3% is bad. It's that if 3% literally meant like 3 out of 100, but let's say it was out of 1,000, well, 3% is okay. It's 30.
Okay.
But you might want to look at that. I will look at that as well here real quick. Do you have a way to quickly access some of that information?
The like the answer to it?
Yeah.
Oh yeah, sure. Let me pull it up real quick. Let me see here. That's definitely not it. So it was.
So I take that back.
33.
Yeah, it's actually the expected value that might be the issue, not the actual cell value.
What it says right here is because we do not have the actual counts of the travelers in each category.
Okay.
We also do not know if the sample was taken randomly or if the samples are independent of each other.
Yes.
Okay.
Okay. So the but that thing with 5 in there, I misspoke on that. That's the expected values. So for 33, we can say that for those reasons you just mentioned, that we don't know the sample size is unknown. We don't know if they're independent or not. And then I think there's one more you mentioned.
Oh, it was just those two.
Okay. But for 34, we actually need to do a bit more here. It was my fault for not. So we'll go back here to 34 here.
Good.
So it's the expected value of each cell has to be at least 5. And I'm sure that's the problem here. So we want to find the row and the column totals.
Okay.
That's 20. So 40. So if we made an expected, we made an expected matrix over here. Did your teacher happen to cover how to do that in class with you?
With the like the calculator or the actual like
well,
putting them in?
the formula is easy, but it's having the calculator do it, like the row total times the column total divided by the.
Right. Yeah, we did go over that a little bit.
But there's probably a way to do it with matrices that we didn't cover. So this top right left cell is 11, the row total times 20 divided by 40. Does that sound familiar to you, that formula there?
I'm sorry. Oh, so it's the 20 times the row total.
It's always the like whichever cell you're in, it's the row total, column total multiplied together times the super total, or divided by the super total. So like I didn't expect there to be an issue there. There might be an issue in the second one, so that's where we probably should go. 7 times 20 divided by 40. And that's the issue there. That's 3.5. And it's not that any individual cells have to be can be below size. It's the expected counts that have to be greater than or equal to 5.
Right. That's it. That's the yeah. Okay.
So in my opinion, you could stop there because you've got one that's less than 5, so you're okay.
Okay, cool. Okay, perfect. Yeah. Huh, okay, so yeah, it's just kind of running through the conditions of like whenever they ask that kind of
Yeah,
question.
and maybe there's something else up here that says that they were independent, so you can't use that, or maybe they weren't independent. I don't know. I mean, I don't. Sometimes I don't know how you deduce some of that from this, but um, this is probably what they're looking for in 34.
Okay, cool.
All right, so let's move on to some other questions here. 35. Alrighty, so this one, okay, this one's the actual calculation here.
Perfect.
All right, so there's some words above there, but whenever you get a table like this, what you need is the data in a matrix, and then you also need the expected values in a matrix. So that's what I was asking, like if you guys had, if you'd figured that out quickly by hand.
Oh, I see. Yeah,
Or
she's mainly kind of put it into the calculator, really. She didn't go too much into the
okay,
on doing it by hand, but I'd love to learn how.
well, I don't know how to the calculator will do the expected ones.
Okay.
I know how Excel will do it, which you don't get, but that's, we're not allowed to Excel. So what I would suggest doing is making matrix A this right here. And I'll get you matrix B, which is the expected ones,
Right.
because we need those for doing the formula. Alternatively, you could put all of these in lists. You could put just the numbers in lists because
Right.
it's the same idea. Like I'll put everything in. It depends what you want to do. I
Okay,
guess
I
I
see.
would tend towards using lists because why would I? Because it'll sum a list a lot faster than it'll sum a matrix. Although I think you figured that out the other day.
Mm-hmm.
So it's up to you.
Okay.
Whatever you're thinking there. But give me 1, 2, 3. All right, so let me get this entered.
Okay. And I believe I got the expected counts for them as well.
Oh, you do?
Yeah, I think so. I'll
Okay.
run it by you.
All right. Well, I'm a little slower here because I got a lot of things
Oh no, don't
moving
worry, you're all
around,
good.
but we'll get shortly. 485. All right, equals. So we want this one times this one divided by. Okay, is your top left, 130.8?
Yep, that's exactly what I
Okay.
got.
All right. I'm curious, how did you do that in the calculator?
So what I did
Sure.
was I put them into the matrix,
Okay.
and then I went over to the chi test, the geo was it, or it was just the regular one, I believe.
Goodness of fit, or just
Yeah,
the
the goodness
chi-square
of
test?
it.
Oh, really? And it'll
And
do it
for
right from that.
yeah, from the expected count, I just put in one of the empty matrices,
I
and
see.
it actually puts in the expected counts for it. So you can go back and go into the edit, and it shows you all the expected counts for each
Perfect.
one.
Perfect. Does that also give you the test statistic?
Yes, it does actually as well. So like if
Okay.
you go back to the tests and you go through with the test, like you enter it,
Hmm.
it gives you all the information. But if you want
Perfect.
to go back and look at the expected counts, you just go back to the matrix.
Great. So let's go through a little bit more here. Degrees of freedom is the rows or columns -1 times columns -1. What would the degrees of freedom be if you had to do it by hand? So you got
Right.
2 columns, 2 -1, 5 rows. The totals don't count. So it's 5 -1 times 2 -1. Degrees of freedom 4. And then your distribution here, you got a chi-squared value and then a p-value.
Yeah, I got 1.814 or 1.815, I guess. If you
Okay.
round it up.
And then what's your p-value?
I got 0.77.
Oh, really?
Yeah.
Okay. So this is much greater. There, I don't know if an alpha level is given. Doesn't
Let me
say.
double check. Selected two bags. It doesn't mention an alpha level, but
Okay.
something that I did notice is that usually she puts in 0.05, like if
Okay.
they don't give you one.
So this is fail to reject
Right.
because the p-value is greater than alpha. Do these data provide convincing evidence that the distributions of color differ for name brand gummy bears and store brand gummies? Generally, these are written in such a way where they're asking about the, like, whether you accept the alternative hypothesis, or not accept, but whether you reject the null and conclude the alternative.
Right. Right. Yeah. No, this one's a bit. P-value. Okay. Okay. Interesting. Yeah, definitely the calculator has been a big help with these kinds of questions for sure. Just like being able to plug it in and like
Yeah.
I did, it's for sure you definitely have to show the work to get like the actual points for it, but for sure it definitely helps.
I recall you could even on the AP though, like just say that you're using the, like you can sort of say in the calculator somehow indicate that.
Right.
Double check that, please. 'Cause I don't know.
Okay, I will.
Um,
Let's see. And did I give you 36 or what was it 36? I think it was a different one.
I got 41 is next.
41. Okay, yeah.
Do we need to go through 36?
No, it's 41.
Okay. All right. State the null and alternative hypothesis for performing a chi-square test for independence.
So let's see. Weekly sauna frequency. So 1 or 2 weeks. The SCD, what is that? Hold on. So, okay, researchers followed a random sample of 2,315 middle-aged men from Eastern Finland up to 30 years. They recorded how often each man went into a sauna and whether or not he suffered sudden cardiac death. Two-way table shows the data from the study. Huh. Very interesting question.
Yeah, I never get too interested in that, but sauna's supposed to be pretty good for you.
Yeah, I definitely go into the steam
Yeah.
room once in a while at the racquetball club for sure.
Yeah. The general null and alternative hypothesis, there's no difference, and then there
Right.
is a difference. And like there's no difference between the two categories, SCD, weekly sauna, or there is a difference between them. And it really, this is like, comes down to how much your teacher wants you to, or you can say, like the one that I prefer is independent and
Independent and then dependent
not independent or
or
dependent.
not independent. Yeah.
Yeah. And it's because that sometimes makes more sense to us intuitively, logically, of like SCD and weekly sauna frequency are independent, or no, they are dependent.
I see. Okay, so gotcha. Or the one that she used is that there's no association.
Okay, there's another one. Yeah, there's like variations on all these that you can see.
Crazy. Huh.
Yeah.
I'm
Well,
gonna
the
review it.
English language isn't great for a lot of reasons like this.
Oh yeah, it's so
Yeah.
true. It's a hard one to learn, I believe it.
Yeah. So however you're supposed to state that in the class, I mean, you got the answer in the back of the book maybe to compare to.
Yeah, usually I notice from the back of the book too, it definitely goes more into detail than how she puts it. So I kind of just like try to add a little bit of both for it. But just because I'm not too sure like how the AP like exam I'm not sure what you call them exactly, but the ones that like score the tests, like
The
which
free response question
yeah,
FRQs.
yeah, exactly. And I do have officially a date for the AP exam too. It's going to
Oh,
be May
nice.
4th. So
All
that'll
right,
be
morning, or is it they're all in the morning, I guess.
noon.
Noon, okay.
Noon. So see if there's a lot of people there or not. I'm not too sure where it is exactly either, but we'll see. But yeah,
Okay, so that's part A.
right.
Part B is to actually probably do the test here. Yeah. Oh no, B is to get the expected counts. So I would do the same thing you just
Assuming
did.
that, yeah, hypothesis null is true. There is no difference.
So my question to you is do you have to specify the size of the matrix, or will it automatically create the size for the expected counts? Like if you give it the wrong size. Like this one's a 2-row by 3-column.
Yeah.
So if you make B like, the wrong one, 3 rows and 2 columns, will it still work?
I'm not too sure. I can double check that and see.
Yeah,
Like
and
if there's
we
like
don't
already a filled out one.
you don't have to waste time. I'm that's the kind of stuff that I sort of wonder when
Oh, I see.
like how helpful is the calculator?
Right. Let me see. Try to plug it in now and see what happens. Edit this one. So it's 2. Oh no, 2 by 3. So you got 61 by 40. Got 919. 1,304. Dang. Got 10. 1. Okay, stat test. Up. That one. Matrix. Yeah, let's just see if we can try to go into B. Oh yeah, I guess it just kind of edits over it really.
That's good.
If you put it in, yeah, it just edits over it. That's interesting.
Cool.
Yeah, very neat. Cool. All right, perfect. Okay, so for
So
the
part
expected
part
count,
C is the expected, I'm sorry, the chi-square after you get the expecteds.
the DF maintain. Oh, okay. I think I have that too as well. See, so B, the expected counts. I'll just plug those in real quick. Do you need the expected counts or?
No, if you got them, I mean, I'm gonna be much slower to do this than
Okay.
you.
1, 7, 2, 3, 8, 16, 184, 5. Okay. And then C is actually the chi, like the actual statistic of it.
Mhm.
Okay, so run over the tests. Okay. The chi-square, I just got 6.03.
Okay.
And then for P value, I got 0.0489.
All right. So if your alpha is 0.05, are you rejecting or failing to reject?
Failing to reject.
Yeah. No. P-value is less than alpha.
Oh, less than alpha. It is less than alpha, actually.
Yeah.
Yeah.
Reject.
Oh, so you wouldn't really round up then, huh?
No, you do not round. That's very bad. Don't do that.
Okay,
Uh,
gotcha.
Yeah. If you're gonna round to like the 4th decimal place.
Gotcha.
So
Okay.
this one you do
So we do
reject,
reject. Perfect.
which means that you conclude that there is a difference, dependent.
Conclude they are dependent of each other. Perfect. Okay. Cool. Let's see. Do we still got some time left? Did I
Yeah,
not send any more?
that's all I see.
Okay, shoot. Let me send over one more if I can real quick. Here. Yeah, just send over this one. Sorry about that. Didn't realize we would jump right through these real quick.
We tend to get through more than most people
Really?
realize these
Wow.
lessons. Yeah, I mean, it's always, more efficient than. All right, so 43 here. Really this is no different than the previous ones. You've got to make a matrix here. of,
I
you know,
see.
your 1, 2, 3, 1, 2, 3. I know you're probably reading the problem. Maybe you like the reading of it. I just look at these. All right, I got to make a table. I got to find the
Right.
expected counts. I got to do the chi-square distribution. Like really, all you care about is the p-value. That
Right.
makes your
Right.
decision.
5, 200. Okay. Stat tests. Okay. Matrix. Edit. Yeah. Wow. This thing works magic, man. I can't believe I didn't get one of these sooner.
That's good. It's good you're seeing that because it'll help in almost everything you've been doing and will
Right.
do the
Right.
rest of this course. And if you go to
Okay.
college, if you're taking classes, they'll usually allow you to use a calculator. So
Can I bring my own, or do they have one specifically for that? Like that, like doesn't have any of the saved data?
you talking about in the AP?
Yeah, like in the AP exam.
I believe you got to bring your calculator. They probably have someone that sits there and resets it for you as you walk in, maybe. But
Okay. All
um,
right. So for
yeah,
the chi-square, I got 2.06.
okay.
And then for the p-value, I got 0.356.
Okay, so your alpha in this case is 0.10. Is this a reject or fail to reject situation?
Failed to reject because it's over the p-value, or the over the alpha level.
Okay,
Okay, and that's the conclusion. And that's the answer to the question. I mean, I know you have to like, she has like a specific way to do it that takes like a really long time, but
yeah, they have like a 7-step process or something, but
usually.
this is the core of it is can you get the chi-squared value? Can you get the p-value compared to the p-value? There's also the critical value approach, which we've not done any of as far as I can tell, but
I think that might be the next chapter if I can. Yeah, the inference for slope, it seems. The
okay, so that'll
distribution.
be regression. You seems like you guys
Yeah,
might
the
have screwed out
regression.
this.
I think I'm definitely gonna have to bring a few more of those because that's kind of where I struggled. Like with this, like the format that she has it, like I was able to kind of understand it quickly. But it's kind of like I have a little bit of trouble with like the testing the 90%, like the 90% interval tests.
Okay, well
So I might,
we can do some more confidence intervals at some point if you'd like.
yeah, I'll
Um,
probably bring them up in the book. Um, but yeah, all right. Is that the end of our class time?
that is everything. That's all we've got time for.